So to derive the aforementioned representation, let's write down the chain rule for the Digamma function for the following argument. As usual, it is the finite sum and let's abort this chain at 1 over z, so we make n steps. Next, let's write down the same chain rule for psi of n plus 1. And again, it's going to be, as before, 1 over n plus 1 over n minus 1 plus 1 plus psi of 1, where psi of 1 is simply minus Euler constant. Now let's subtract these two equations and set n tending to plus infinity. So as we have proven before, the left-hand side will tend to 0. Now what about the right-hand side? Well, the right-hand side will turn into the difference of two finite sums, which in the limit n tending to plus infinity will become an infinite sums. So let's write them as follows. N going from 0 to, okay, k going from 0 to n, but n tends to infinity. 1 over n plus z. Sorry, let's make this k to avoid confusion. K plus z minus 1 over k plus 1. So that's the difference of these two sums. And then there is one more term, which is minus gamma plus psi of z. And here comes one of the most important representations of the Digamma function, which is simply the following sum and minus Euler constant. And we'll see in a second how this equation helps us to compute quite challenging integrals and sums.